Now we will be determining stability. We determine the stability of the air by comparing the temperature of a rising parcel to that of its surrounding environment. If the rising air is colder than its environment, the rising air will be more dense, means the rising air would be more heavier, and then the rising air will have a tendency to sink back to its original level. In this case, the air is stable because the air will resist upward movement. If the rising air is warmer and therefore less dense or lighter than the surrounding environmental air, it will continue to rise until it reaches the same temperature as its environment. So this is an example of unstable air. To figure out the air stability, we need to measure the temperature, both the rising air and of its environment, as various different level above the earth. So suppose that we release a balloon borne in instruments that we usually call it radiosonde, exactly as the picture. Uh, as the balloon carries the radiosonde upward, the radiosonde send back temperature data, as you see the graph. So this graph is such a vertical profile of temperature, and we call it sounding. So if you notice that the sounding measures the air temperature that decrease a certain rate with the increasing altitude, so the rate at which the air temperature change with altitude is called the lapse rate, because this is the rate at which the air temperature surrounding us will be changing if we were to climb upward into the atmosphere. And this situation, this changing, we will be referring to it as an environmental lapse rate. Now if we look at this figure, that a parcel of unsaturated air with a temperature of 30 degree is lifted from the surface. As it rises, it cools at the dry adiabatic rates. The dry adiabatic rate is 10 degrees centigrade per 1000 meter, and the temperature inside the parcel at 1000 meter would be 20 degrees centigrade, or 6 degree lower than the surrounding air. So if you look at this figure very closely, and if you will be noticing that as the air parcel rises higher, the temperature differences between it and the surrounding air become even greater or larger. So differences is getting larger. Even if the parcel is initially saturated, it will cool at the moist rate. The moist rate in this figure 6 degree centigrade per 1000 meter, and will be colder than its environment at all levels. So moist adiabatic lapse rate is less than the environmental lapse rate here. In both cases, what is happening? The rising air is colder and rising air is heavier than the air surrounding it. So in this example, the atmosphere is absolutely stable. So we can say the atmosphere is always absolutely stable when the environmental lapse rate is less than the moist adiabatic lapse rate. So an absolutely stable atmosphere occur when the environmental lapse rate is less than the moist adiabatic rate. In a stable atmosphere, a rising air parcel is colder and more dense than the air surrounding it, and if given the chance, it will return to its original state. So this is how the absolute atmosphere works. As we know that to be an absolutely stable atmosphere, the atmosphere is always absolutely stable when environmental lapse rate is less than the moist adiabatic lapse rate. Now, what conditions are necessary to bring about a stable atmosphere? As we have just seen, the atmosphere is stable when the environmental lapse rate is small. That is when the difference in temperature between the surface air and the surface above is relatively small. So that brings the stable atmosphere. Now, the cooling of the surface air can be done by some thing like nighttime radiation cooling of the surface, an influx of cold surface air that brought it by the wind. That we know that advection is the horizontal movement of the wind, so the cold surface air brought from other place to the relatively warm place and make the adjacent atmosphere cool and heavy and stable. Air sometimes moves over a cold surface when the relatively warm air moving over the cold surface, that's radiation, terrestrial radiation, making the adjacent atmosphere to the ground is more stable. So on a typical day, the atmosphere is usually mostly stable in the early morning around some time before sunrise, when the lowest surface air temperature we can record, because that is the time relative humidity is the highest and temperature is the lowest. So if the surface air become saturated in a stable atmosphere, a persistent layer of haze or a fog we can see in the stable atmosphere. Another way the atmosphere becomes more stable is when an entire layer of air sinks down. For example, if a layer of unsaturated air over approximately 1000 meter thick and it is covering a large area of subsides, that this situation, the entire layer of atmosphere will warm by the process called adiabatic compression. As the layers subside, it becomes compressed by the weight of the atmosphere and the consequently shrinks vertically. So this happens. The upper part of the layer sinks further and warm more than the bottom part. So this is happens when the subsiding happens. So after this subsiding, the top of the layer is actually warmer than the bottom, and an inversion situation formed. So an inversion represents an atmospheric condition where the air become warmer with the height. Inversion that form as the air slowly sinks over a large area are called subsidence inversion. They sometimes occur at the surface, but more frequently this subsident inversion are observed at the higher altitude and are often associated with the large high pressure system, because the sinking air motion associated with these kinds of high pressure system. So as inversion represent an atmosphere that is absolutely stable. Why is that? Within the inversion, we know that warm air overlies cold air, and if the rise into the inversion, that means this air rises into the inversion, it is becoming colder. So while the air around it is getting warmer, obviously the colder air would tend to sink. Inversion therefore act as a lead of vertical air motion. So at this point, we can see why extremely high surface temperature can occur when the air is aloft is sinking. So the whole situation, we know that a stable atmosphere is caused.